Okay, I will bring up the slide deck while we are waiting for, we'll give 1 or 2 minutes. I see Jntuk Kakinada there. Good morning, everyone there. They have a very nice conference room there. And SVCW, if I remember right, they have some kind of a conference type setting. I see PSCMR people there. Aditya College of Engineering is there. Osharama College, that's good. Okay, that's excellent. I did not turn on my video yet. And let me mute everyone. Okay, I think I muted everyone. Bolisetti Santoshi. I don't see them on audio. Okay, this is good. Okay. Let me close my stuff here. While we are waiting, let me see what I can put in terms of a quote, right? Substitute for dedication and hard work. Okay, I think that's a good thing to say, whether you want to call it quote or Pratap's quote, right? Okay. Let me go to the slide that I wanted to show you guys. So, what did we learn last week or the last class? You can put it in the chat for me. Just summarizing what we learned last class. Who wants to start putting things in the chat? Good morning, Aditya. I see you there. I think we learned a few things, if I remember right, in the last class. Students can ask your facilitator to put the things in the chat, or you can go in front of the room and type it in. Maybe Aditya, since you're typing, you can type there. What did we learn in the last class? What was the topic for the last class? Searching and sorting, right? Within that, we learned a few things. What did we learn? If you remember. Kind of like I tell my students here, my brain, I only have RAM. I don't have any ROM. So after I teach the class, I get out of the room, then I don't remember anything. It gets flushed out of my mind. Till the next class, I don't remember anything. Okay. Now, somebody said, sir, bubble sort. Thank you, Shagaru. Correct. And then we touched upon another sort too, right? Selection sort anukuntanu, if I remember right? And then we briefly touched upon some search. Okay. So This is today. It's going to be. I'm going to be relying on all the mentors because remember I told you as we get deeper now, you will be doing more exercises and hands-on in the classroom. So while the students are doing that, when I give instructions, you will be following it. Okay, fair enough. Okay. Now, as always, before the class, I always start with something, right? Either a quote or something like that. So why did I start saying there's no substitute for dedication and hard work? Because there's something called, if any one of you have heard about it, you can put it in the chat. There's something called a growth mindset. Mindset, one word or two words, I'm not sure. I think it's one word. Has anyone heard about the growth mindset? Question open to faculty members too and students also. There's a very famous professor. You heard. That's very nice. So you know who gave that? Querel Dweck. She's a Stanford professor in psychology. Ignore my typos, please. Right, this WebEx whiteboard is pretty clumsy. So what is growth mindset? Uh, Many of my classes, different things from different walks of life. So that way you will all learn something, not just the subject, but other things too, right? So that the sentence that I wrote above, there is no substitute for dedication and hard work. So she basically showed that yes, we all are born with brains, most of us. Okay. And then there's talent. We always say there's a talented guy, intelligent guy, and all of those things. All those things are great, but they don't count for anything unless you are dedicated and you work hard to achieve results. Okay. And then she showed in her thesis that talent alone is not enough. Having great brains alone is not enough. One can actually, even people who are quote unquote a little bit less talented, they can actually grow their mindset, meaning you are not limited by your brain and the so-called talent. So a lot of people when they say, "Oh, I have a fixed mindset," meaning, you know what, that is my capability. So you give up, right? What she said, no, you should not do that. You should develop a growth mindset where you, by showing some focused uh, practice or dedication to achieve something, you can grow your mindset. That means you can become better. So to contrast, it's fixed mindset versus variable mindset. Talking computer language, then they will always be having fixed capability. For people who say, you know what, I'm going to improve. Okay, that is the growth mindset. Now there are a lot of theories, right? Like growth mindset doesn't mean that you it's kind of like an abused term by teachers here, especially in high school and middle school and so on. They praise the effort of a student. Say, okay, you at least get the growth mindset. says is we should analyze how you prepared, what was your strategy in terms of doing it. Can you improve upon the strategy next time? That is what growth mindset says. Great attitude for students to have the growth mindset in your careers. Okay? That is the moral of the story in today's class. You can Google up and read all about it. Okay. Are we ready to do stuff? So last time we kind of stopped somewhere around the selection sort. Um, I showed you what selection sort is. We'll come back to it. For those of you who remember it, great. If you don't, guess what? Today it's going to be mostly hands-on. I'll probably cover maybe 6 to 10 slides at most. Most of it would be hands-on. And the way the hands-on is going to work, you can see right at the bottom. Okay, we are starting now. Basically, what you do is okay, pace of 2 is a good one. You can learn from each other in doing that. And I'm going to give you a whole series of exercises based on the sorting algorithms. And after you do that, if time permits, I will introduce you to a couple of other algorithms like quicksort. Okay, in particular quicksort. Sounds like a plan? Do you all have sheets of paper there with you? Printer paper, Gani Atla. Mentors, please ensure that they all have access to sheets of paper or their notebook and a pencil. Then we can do a lot of fun stuff. And then keep your video on so that way I can see that they are all working. That will be very exciting, right? Okay. So let's start with you might laugh when I just put BS, right? BS could mean BS really, right? What I mean is bubble sort there. Don't get any ideas, okay? That is bubble sort. Okay. So how does the bubble sort work? I kind of asked you some questions, say, what happens after iteration one and things like that, right? Also, one faculty member in our faculty meeting that we had yesterday or day before said, can you show animation? I said, it is coming. We'll kind of show different types of animations or pictures to convey the concepts. Better yet, experiential learning, right? You experience how it works by doing it on a piece of paper and you learn. That is what you'll be doing here today. So what is happening with bubble sort? So you're given an array. By the way, I just copy paste a lot of stuff from different sources. Okay, guys, you have to hold on. I have to close my office door here. Give me a second. Okay. Did I miss one shot here? I missed one thing here. 33 and 27. I did not I did not do that one. I should say technically we say 33 and 27. 33 is greater than 27. So you can see in the next row how those numbers got swapped. Okay, easy stuff, right? Okay, now wherever the pointer is, that last element where the swap happened, right? You compare 5. Have to do anything. Now you increment the counter to 35. Always that last position, right? Element 10. It requires a swap. Understand? Is this clear enough through the picture? Show of hands, JNTU Kakinada. Do you understand the picture? Then raise your hands. Okay, I see some of you raise the hands. I'll go over it just one more time so that way I can expect to see all hands raised. Okay, so you're given an array of elements. What is bubble sort doing? It's comparing the first two elements. Okay, if they need to be swapped, it will swap based on whether the first number is less than or equal to the second number. Okay, since they're already sorted, no problem. So from one is greater than A2. So now moving to A2. 33. Okay, they're already sorted. Compare that with the next element. 35 is compared with 10. Okay, since 35 is greater than 10, you swap, as you can see in the last row. Comparison stopped. So this entire thing is one iteration. Okay, now because of low bandwidth. Okay, now the question is this: mentors, you are there to help them understand this, right? So, okay, now show of hands. I see the video. Do you understand it? You can raise your hands if you understand it. Great. So what I want you to do, all of you, each class, I can already see Usha madam doing it, mentoring, giving out paper and all that. Thank you. So in pairs of two, show the trace for the second and third iteration. So I showed you the first iteration. Okay. At the end of the first iteration, from top to bottom, because you have to compare all elements, I mean, from the pointer onwards to the end of the array. After I finish until end of the array, no more comparisons left. You see how at the end of it, I got 35 here. Okay. What would be the trace for the second iteration? Okay, you do it, and then I'm giving you how much time I'm giving you. Uh, I'm giving you about 15 minutes. How about that? Okay, let me give you 15 minutes for this. Okay. Mentors, mentors. Actually, I said 10 minutes. I don't know why I said 15 here. 10 to 15. Okay, let me be generous then. If you're done sooner, just say we are done, then we can move on, right? Sometimes I might give more time and you're all too smart and we'll finish it in half the time, then we move on. Sometimes I give less time and if you need more time and you'll finish it in half the time, then we'll move on. Sometimes I give more time, then we move on. Sometimes I give less time and if you need more time, put it. So I need 5 more minutes. You can put it in the chat. Okay, ready, go. Time starts now. Okay, I'm muting people so that way there is no static.
ఇవాళ ప్రాజెక్ట్ లేదు మానిటర్ నెక్స్ట్ అవర్ వస్తే రావచ్చు ఓకే
Let me I did not turn on my video. I did not turn on my video. Okay. Does everyone understand the exercise? Does everyone understand the exercise? The video is coming on again off. Jntuk exercise. You can raise your hands if you understand what you're your video got cut off. I put it in the chat. Okay, in the chat. Okay, SV 11:15. So 11:25 your time. By then you give me some idea whether you're all done. Mentors, you can put it in the chat for me if you're if most of the students in your classroom are done. You can say we are done. That will tell me how many of you have completed. Then we can move on to the next one. You are too fast. SVCW is saying they are already done. You showed the iterations like that, as I told you. Okay, all completed. Excellent. I got two of you. Okay. Okay. Great. Two colleges have completed. That's good. Okay. Three colleges have completed. That's good. How many? Okay. JNTV done. Four. Okay. Usharama College, Aditya. And I have Pragati. Okay. Pairs of two. Let me also, people who said you have done, can you do me a favor and put me how many students you have in the classroom? Each of you said you are done. Would you please put how many students you have in the classroom? And then I'll divide it by two to know the pairs. Okay. 52, 46. By the way, private ka pettakkarledu. You can put it in for everyone. That should be fine. By the way, some of you who are done, DMS if 30. Uh, if you are done, you can review the couple of slides that I posted before on the selection sort. 47, that's good. Okay, I'm waiting for a couple of more colleges to finish. To be fair, others who have finished, they can review the slides on selection sort because we'll be doing an exercise on that also. Still have time, go take a break. Get yourself a cup of tea or something. So for those of you who have done, you can do one more thing too. Without looking at anything, write the algorithm. I showed you visually what needs to be done. Can you write as close to code as possible for that, or an algorithm? Joshi, that is a different college, right? And I'm waiting for Aditya also to put something in the chat for me, if they are done or not. I'm always super impressed with JNTUV. Their classroom is always packed. They have a lot of students there. 98, there you go. Almost close to 100 every single class. But these are good numbers, okay? SVCRB are good numbers. Excellent. I don't want to hold up everyone else, but is it okay if I move on to the next slide? A couple of colleges have not responded yet, but you can certainly make them do it as we keep going on, okay? Otherwise, other students would start complaining. We have to sit there doing nothing, right? Okay. Now, while you're continuing, I want the same thing to happen for selection sort. Okay. And once you do the trace, people who have finished, they can start working on this. Once you do the trace, I want you to understand the difference that you notice between the two sort algorithms. Okay. Think about what is the difference between the two. Okay. Now, after you think about it, last one, how do you know? I have a typo there. How do you know when to stop the program? Right? I want you to think and tell me how you would ensure the program stops. Okay? And after you do these three things, then you have this other question, right? Saying is selection sort always stable? Remember, I gave you the stable definition last time. Okay? Now, you can say yes or no, but if you can demonstrate your answer with an example, that will be fantastic. If you cannot do it, that's okay, but give it a shot. Okay? Do you understand the question? Similar to the first question, right? People who have done fast, I'm assuming they know that. For the benefit of the students, let me show you the selection sort was discussed just before we wrapped up the thing. This is the algorithm for selection sort. Okay. I'll put that selection sort steps there in that slide. Okay. I'm copy pasting those steps. Let's see, where can I post it? If I put it here somewhere, will it come? Yeah. Okay, that is the algorithm for selection sort. Okay. Do the same thing. Trace it. Take that top row and apply selection sort and see how the trace looks like. Do it in teams of two. And once you're done for selection sort, you can put it in the chat that you have done. That way I know how many of you have done. I know you'll take at least 5 minutes. I will go get myself a cup of tea in the meantime. I'm muting myself. That's good. I saw Pragati rearranging themselves into pairs of two I think they finally got a kick out of it, I think now. Mali, are you getting it? Okay, good. So I think there's some friendly competition I should put. See, that's kind of interesting, right? That's what happens when you do a MOOCs class online. I can make each one compete against each other. Kind of fun, right? It's like bragging rights. So if I were to ask you to show the piece of paper where you have written, can you show it in the WebEx? Because in my software engineering class, when students did that, they used to show their work. Okay, while you're doing that, let me check my uh, community and see how many students are there. My screen would have gone blank, but you know what you're doing. So I'm just checking our community here. And then when you're done, you can put it in the chat. I'm Ushagaru. I'm going to show. One way is you can scan it, right? Take a picture, scan it into your computer or in your email or Google Docs. And then when I make you the presenter, I can pass the ball control to you. Then you can do share screen and then you can show it. 249. 249 was the same as last time. So one of the things that we discussed in our mentor interaction class, some of you missed it. We said each one of you should take a roster. I wanted a roster of all the students in your respective classes, their name and email ID. You can ask them to create an Excel sheet, or you can ask them to write on a piece of paper that you can take a picture and send it to me. That way I know the total count. If that is something that you can do, you can even pass a sheet of paper right now in your respective classes. Ask each of the students to write their name and then name and email ID. You know what? Let's put them on the spot here, right? Also put another third column called, did you already sign up on Lensu or not? Yes or no. So that way we would know who else has not signed up on Lensu. So that way we can go after them and make sure they sign up. Okay, so far I only got JNTUV who said they completed selection sort. Who else completed selection sort trace? Now, did every college complete the bubble sort trace now by now, or is there anyone who's still working on bubble sort? I'll okay, completed, sir, including algorithm. Excellent. Uh, is there anyone who is still working on bubble sort? How about we give you a few more minutes, because only JNTU-V and JNTU Kakinada finished selection sort. Oh, DMS, good, 3. If I get one more or two more, then we can move on. That's excellent. Aditya was silent today. I don't know why. Aditya generally does it pretty fast too, but today they have not posted anything. Do you have the facilitator there today in the classroom or not? So some professor in JNTU Kakinada tells me there's a uh, they speak very highly of JNTU Vijayanagaram. They always finish fast and things like that. He was telling me once. So it's kind of like a nice healthy competition between different colleges. So DMS also is doing fast. I can see from the responses here. SVCW also does a pretty good job. Usharama College, how are your students doing? Are they finishing the tasks there, or if they're having any challenge, please do let. Okay, one more. I'm waiting for one more college to say they're done and we can. Okay, for people who have finished, right, let's move on, right? So you showed the trace. Let's see the second question there, right? While people are working on, what is the difference that you notice between the two sort algorithms? Did you folks did either JNTUV or DMS or JNTU Kakinada? Did your students answer that question too? What is the difference that they noticed between the two sort algorithms? You can put it in the chat. Is that a tough question or is the question not clear? So what is the main difference between the selection sort that you noticed when you're tracing and the bubble sort is the question. Ushagaru, you can ask that question to your students and see if they have an answer. Same thing for JNTV. And of course, same question applies to rest of the college, to including DMS. I thought it shouldn't take more than a minute for you to tell me what is the difference between the two. If you traced it, you already know what happens at the end of first iteration. In both the cases, that should bring out the difference between the two. Pragati, go for it. If you know it, go ahead and answer. I do see you are intensely doing your work there. I see your video. I'm not seeing. Good morning, ABRCET. Okay, somebody put something there. Bubble sort, they involve the adjacent comparison of array elements only. Okay. Carry on. What else? What does it mean? Yeah, that's true. But what is the big thing that we see? What is the big difference that we see? Like, for example, if I have to give you a hint, at the end of first iteration, pretty much the is the sort order coming from the last, the highest element going to the right place in the first iteration, right? In the case of bubble sort. And in the case of selection sort, the smallest element is going to its place first. Correct? Exactly. That's what I was looking for. DMS, you got it. Okay, Pragati. In the last class, some of us were absent. Will you please explain the selection sort again? Oh, yeah, absolutely. I'll be delighted to do it because it is the easiest to explain. It is stated right here. How does selection sort work? It works the following way. Oh, why is it going to that? Okay, let me go. See this one here? I'm highlighting it. That is selection sort. So you're searching through the list. Okay, 14, 33, 27, 35, 10. So you're searching through the list and you're finding the smallest element. Okay. And then, so you're basically doing some kind of a for loop there, right? For I equal to 0 to I less than or equal to n. Okay. And you have written a program to find the smallest element, right? So then if once you find the smallest element, initially, where do you want to place it in A0, right? So you'll have some variable which keeps track of where the element is placed. So initially, element to be placed would be A0, right? So you'll place that in A0 and then you increment that counter. Then you take the rest of the elements, find the smallest. Then you put that in A1 and so on till you exhaust all the elements of the array, right? That's all you're doing. So once you've done with the first element, then your data set becomes from second element to that one. So if I have to show that one here in this one, so you say for I equal to 0, 1, 2, 3, 4, 5 less than or equal I equal to less than or equal to 4, right? Because our numbering starts from 0, 0 to 4, 5 element array. So you say you try to find the lowest element is 10. Okay, that 10 gets swapped with 14, right? You have to move 10 to this area, so 14 goes to the 10th place. So if I have to draw a small thing here, so 10 gets here, then 33 remains like that, 27 remains like that, 35 remains like that, 14 goes there. You agree? Okay, once we do that, let me overwrite this one. Let me move this one for the sake of writing here. So now 10 is done. We'll not worry about that. Then we'll only worry about, so 10 carries over to the next one like that. We'll worry about 33, 27, 35, 14. So 14 is the lowest element. So 14 goes there. You get 27, you get 35, you get 33. What comes next? 10, 14. Is there anything to swap? There is nothing to swap, right? 27 is the lowest. So 27 remains there. You get 35, you get 33. Now that you're done with 27, those remain constant. 10, 14, 27. Then you say 35 and 33. So 33 is the lowest element, so 33 comes here. Then you goes to 35. You got it? Um, okay. Somebody who was the one who asked the question since some students. Okay. So Pragati, you understand now? The students in Pragati. So moral of the story, moral of the story is don't miss classes. Unless you have to go see a Mahesh Babu movie or a Pawan Kalyan movie or Samantha movie. Boys would like Samantha movie, I'm sure. Okay, like right? How many of you have seen movie? We'll talk movies also in my class. I have seen it. Okay. Here, by the way, the Indians here are so crazy about these movies. Uh, we go to first day, first show movies, you know. We pay $25 for a Mahesh Babu or a Pawan Kalyan movie and see that, even though it's a crazy movie. So we see a lot of movies. I didn't get chance yet to see the movie Sultan. Already my wife, kids, everyone saw it. I'm yet to see that. Okay. Whenever I feel like going, I suddenly realize that day I have a class to teach for Jntuk Kakinada, you know. There goes my movie. Okay, Pragati, thank you. Glad you understand it. Pretty simple. Now, why did I make you do these things, right? You might be wondering. First of all, of course, it's fun practice, right? I told you it's all experiential learning. Unless you do it, you don't get it. Okay. Um, but there's another underlying meaning. What we are basically doing here is I'm teaching you indirectly. I don't know whether you thought about it or not. I'm actually teaching you testing. Since I'm teaching you testing there, right? So you write a piece of code or an algorithm. You're doing your QA testing basically. Okay. Um, I don't know if you touched upon it when you did your C programming class, but when you come and take my software engineering class, I'll do a software development life cycle. Okay. So remember that always whenever you write a program or an algorithm, take some test data like that. You don't have to execute the program on a computer, right? You can take the test data, walk through, build some traces like that to verify that your code works. Okay. Without even having to execute that. Okay, now there's one more thing here I asked, right? Where did I go? Previous slide. Just overwrite like that, don't worry. Um, there's another question there, right? What do you know? How do you know when to stop the program? That's a nice question, by the way. Interesting question. Okay, somebody's writing. One second. DMS SVHC. Sir, if possible, try to explain C code because students have to implement C program in DS lab. Okay, excellent. So um, I gave you the algorithm, right? I think I showed you. Let me go back to one of the slides here, right? Good question. Let me clarify. Okay, let's take this as an example. Okay, um, does this look like a Java code to you on the top? Kind of, right? The moment you see public void selection sort granted. Okay, but the moment you ignore the fact that it's public and void, okay, the until this point, does this all look like almost C code? What is the thing that is not C code there? There's only one thing called list.length, right? Because this comes in Java, list.length. As I was explaining to you in the previous one, this is called the object, where this function. For example, let's say remove that one. Does that line look like C code to you? Yes or no? Show of hands, Pragati. Does it look like C code? I can see your video. JNTU Kakinada, I can see that. Does it look like C code to you? Once I remove dot notation there? It is, right? So for convenience, when I examples are in Java, whether we like it or not, right? So wherever I want to explain that one in the context of that, I would still show you the essence of it. So all this is the same thing, whether you do C or Java or PHP, doesn't matter. A for loop is a for loop, right? A variable is a variable. The only confusion that you might have one time is if you see the dot notation. But once I explain it to you once or twice, hey, dot notation is nothing but later on you learn object-oriented technology. What comes before the dot is called object, and what comes after that is the function, right? So if you look at my slide deck, for those of you since you have not done Java, all you have to do is ignore that the dot notation and everything else looks like C to you, right? Now how to write the function here? You can remove this one, right? Now what does it, so it takes an array, right? So you can say selection sort, it's some kind of an array it takes, so you can use the C syntax to show how you pass, how a function can take a array parameter, right? If you are a programmer who has learned pointers, then you would use pointers there, char star or int star, right? Otherwise, you can send a static array. Pretty straightforward, right? Okay. Now, if you still have difficulty even after explaining these things, to me, whether it's C or Java, the code looks the same to me. Once I know that small nuances, right? Okay, increase the font size. I will do so. Okay. So, but if you do get lost, please let me know. I'll be happy to convert that into total C code and show it to you. Okay. But I think you're smart. I have enough trust in the student that they can figure it out once they see some code. Okay. Now let's go back to this one. DMS, hope I answered your question. But if your students have any difficulty, let me know. I'll be happy to convert everything to C. Okay. I just want them to get a feel for Java also. Okay. Now I had another question here. How do you know when to stop the program? Who can answer that question? Algorithmically. You don't have to show me in code. Tell me how you would stop it. Okay, Usha in JNTU Kakinada said after doing n minus 1 iterations, we'll stop it. Now the full sort even in the first loop, right? For I equal to 1 to n low, you'll do that. So you're saying after you do n minus 1 iterations, you stop it. That's what you meant, I think. N minus 1 iterations. So if I have 5, so after 4 iterations. Okay, that's one way of looking at it. What about selection sort? That also you'll stop after n minus 1 iterations. That's another good way of looking at it. You stop it when there are no exchanges. That is what I was looking for actually. Good one. Because the moment there are no exchanges, you know that uh, uh, that it is done, right? Algorithm. Now, but is that true? Yeah, I think that is true. Correct. If there are no exchanges, right? So you somehow keep track of whether there's an exchange or not. Whenever there's an exchange, you look at that value, and after the iteration, if the value did not change, then you can stop it. Different ways, right? These are all some small tricks. Good. Did anyone attempt to do whether selection sort is stable or not? What does stable mean? Stable means if the same values are there, they maintain their respective positions, right? So if I have a value here, if I write here, continuing this one, let's say if I have 10, 14, actually I'll take letters here, okay? That way it's easy to demonstrate that, okay? If I have uh, A, A to start with B, B, just to differentiate capital B, let's say A, C, okay? So, and then alphabetically A is less than B, B is less than C, okay? Let's assume that even if you look at ASCII code, that is true. So when I do the selection sort, you're going to the list and you'll find A, right? So you're going to find A, you're going to put A there. You're going to have it, I don't want spell check. You still have the B right there, and then the B went here and C. Did the B's maintain their respective positions? They did not, right? And the capital B was supposed to come before small b, but now after the swap, capital B is beyond after small b. Stability means the same values should maintain the same respective positions. This demonstrates that they don't maintain the respective positions, so the selection sort is not stable. Okay, I'm giving you simple answers. Okay, not like research level stuff. Okay, so sometimes it is stable and sometimes it's not stable depending on the type of data that it has. Everyone understands that? I don't know if in your internal exam they'll ask you such questions. I typically ask my questions demonstrate your understanding. That's one of the standard ways I would never ask them to memorize anything. If they have to demonstrate something, I can even give algorithms in the class in the exam paper, then I ask them to demonstrate it. Okay. Questions, comments? I got some water. Take at least one sip. Good. This is fun. Now, there's another sort, okay, called insertion sort. By the way, when we are talking about these things, right? Remember I said at some point I'll do a formal introduction to the big O notation. Uh, but before we do that, you can actually, whatever you learned so far, you can go back to these algorithms and count the primitive instructions and see what is the complexity that you would come up with. And I showed you how to determine that, right? You count the most important primitive operations. Like in the case of the sorts, there's a comparison operation and there's an assignment operation, right? Swap. So you can count the comparison and the assignment and the swaps between the bubble sort and then the selection sort and see which one have primitive operations, right? Less number of primitive operations means better algorithm it is, right? Okay. At a high level. Again, everything is at a high level, right? Because when you go deep into computer science, you will know there are a lot of other variables. Okay, here is another algorithm, which is again of the order of n squared. This basically says it's n squared, n raised to 2. Okay, and then there's an algorithm for that, right? What does it say? We assume the first item is sorted. You compare the second item to the first. If smaller, swap. Okay. After you do the first two items swap like that, then you take the third item, compare it to the fourth item. If they are smaller items, you swap and you keep going on like that. Okay. Now, can you remember these algorithms like that? It's easy to say that on a piece of paper, but suddenly you forget. Okay. But it's okay. Even if you forget, as Einstein said, if I can find something in the book, I don't need to memorize it. So Einstein never memorized equations. He said they are there in the book. And since I cannot remember stuff, I always quote Einstein saying, hey, just like Einstein, if I need to find it, I'll find it. Anyway, going back to this one, you can see slight variation in the sort. Convince yourself, just go. I already gave you the methodology, right? Take the numbers, right? That I gave you, do the insertion sort on that and see how the trace would look like. So stare at the traces of the three algorithms, bubble sort, selection sort, and insertion sort. That way you gain more insights. Okay. By the way, don't need to write any of these things because everything would be posted there. Okay. In the community. So here is some code for insertion sort. Um, Bits and pieces of code. Ignore the dot. The moment you ignore the dot notation, everything else looks like C code as I mentioned to you. Okay. Okay. Now, even though I said fun time with IS, let's not do the trace right now. Okay. You can save it at the end after we finish some more slides. Okay. Uh, okay. Now, interesting question comes about. Again, you don't have to answer it today. This is food for thought for you. I will post this question in the community and you can answer it there in the community. Okay. So I'm asking basically which algorithm do you think will be faster for random data, selection sort or insertion sort? Okay, and you have to justify. Okay, um, I do have an answer here. I don't know whether I should show it or not. It's okay, I'll show it. I'll post some other question in the community. The reason why I'm introducing you to some of these things is right. This is exactly what you do in the industry. You have to be able to justify your approach to a problem solving to the client. Why is it that you're doing that way? Okay. And we ask questions. I'll give you a very practical example. Just today, my colleague got back to me saying, hey, Pratap, I asked you to produce data for the entire quarter. Quarter meaning every 3 months, right? So in Cisco, this quarter is May, June, and July. But I produce data only until end of June. Okay. And she says, hey, you violated my request. I said, but why do you need it? According to theory, according to what we do, the right thing to do is only to produce until end of June. Okay. You get back to me, justify why you need it till end of July by default, then I'll be happy to do that. So it's always about justifying what you're doing. So same thing, you as future engineers, when you're writing algorithms, this is the type of analysis that you need to do and justify. So you don't need to read all of those things, but you can see ultimately we go down, we do the analysis based on the order notation. Okay. Uh, so you can see that in general, like you have selection sort has order of n time, whereas the other sort has some other order. So you compare and contrast like that. Okay. Don't need to memorize this one, but that's a tough question. Do you people go to, let me ask you a question here. How many of you use Stack Overflow? You know Stack Overflow? I'm seeing DMS. Do you show of hands? Do you know Stack Overflow? How many of you don't know about Stack Overflow? If you don't know it, then raise your hand. Okay. Great resource for programmers, right? So Stack Overflow, what else is there? I can point you to. You can go to Quora. How do you spell Quora? Quora Ankunta. Okay. Go to Quora. You get a lot of answers there. Okay. There's something else. Tutors Point Ankuntana. Let me put it somewhere else here. I think it is Tutors Point. You can Google up. You get excellent tutorials there. Okay. That's the reason I was telling the fellow mentors in the other meeting. I said, I consider myself a coach and a facilitator as opposed to a teacher in the traditional sense. I don't need to teach you every single step, right? You're smart to figure that out. Okay, continuing. I wanted to come to one algorithm today. So most of these algorithms, right? When you see that, you require time to finish that particular code. N means if there are n elements in an array, n raised to 2 is what how much time it takes. That's what we say. Okay. Now n squared is very bad. If you look at matrix multiplication, you'll get 3 for loops. For I equal to 1 to n, for j equal to 1 to m, like that. 3. Order of n cube. So the goal is to reduce the time, right? So people have come up with different algorithms. I won't cover this, but I included that in the left it there in the slide deck. Okay. There's an algorithm called shell sort. Okay. Uh, Now you're getting into some algorithms which are not very intuitive. Bubble sort is easy to understand, easy to explain. Okay. Selection sort was okay too. Okay. Insertion sort is here. Look at it. Now it becomes easy for me, right? I say, hey, look at the algorithm that I gave you there. Use the data that I gave you and trace it, right? You can see the trace is right there. Hands-on experience as to how to trace it. Okay. So after the class, if you want to, even if you don't learn shell sort, you're not going to lose anything. I don't think it's part of your syllabus, but it is there if you want to know. Interesting algorithm. I actually don't even remember this algorithm, so even I had to do it on a piece of paper before the class to convince myself that, hey, this is a nice way of doing it. Okay. They gave you enough examples for you to look at that. Some code. Now there's some different tables you can look up. This is one way. I'm not too happy with this particular table. I'll find you another better table to compare the various sorts. It is there in one of my slide decks in the other data structures class that I have seen. But you can see as the number of items increase, right? What is the pattern that you're seeing here? As the number of items increase to be sorted, right? It is said that quick sort wins over. Okay. So if you see as the more number of items are there, you can see quick sort numbers seem to be better. You agree from the table? Okay. So what is that quick sort? Let's look into that, right? First, we have to pay homage to the guy who invented it, Tony Hoare. Okay. You can Google up Tony Hoare. Very nice man, very famous scientist, computer science faculty. Um, interesting as an interesting tidbit about him is he does not have a PhD. Okay, I think he just has a BS in engineering. I think not even masters. I don't know. Common sense, right? When you have large data sets, you divide and compare partial sets. Then you merge the results. Okay. And here is the algorithm. How does it work? If the list has 0 or 1 elements, it's already sorted, right? 1 element, there's nothing to sort. Okay. This is where he differs. He says pick an element P in the list. If there are 5 elements, you can pick any element, call it P. Okay. P stands for pivot. Becomes your reference point. That's what a pivot means, right? Once you pick up a pivot, you're going to divide. Okay. So partition the list minus the pivot into 2 sublists according to the values less than or greater than the pivot. Okay. Then you return the quick sort for the first list. Followed happened here. Okay. Give me a second. Sort of the first list followed by the quick sort of the last list. So let's look at it in action. Okay. Let me put it in presentation mode for you. Okay, so here is the, oh, we used to go to Yahoo Answers. Okay, Stack Overflow. Stack Overflow has become like the standard reference site for all programmers. Okay, okay, they have become so popular now to write some code. They go and put a question there. How do I write this code and what is the algorithm I need to use? Somebody in Stack Overflow would answer that and they'll go implement that. Okay. Okay. How does the quicksort work? Same thing. Take an example and do it, right? So here is the data. Okay. I want you to pay very close attention to this. Okay. Because this is very fun algorithm. Okay. You have this data. You're picking the middle element. What is the middle element here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers kada. So pivot is the 46. You always divide by 2. Even in odd, you do a integer division, pick the pivot element. Okay. Once you pick the pivot element, you have two sets now, right? Anything less than 46 is in one set. Fair enough. And anything greater than 46 is another set. Okay. Then you apply the quick sort to 23, 17, 5, 33, 39, 11, less than list. Now what is the pivot for that one? 33. Okay. You can pivot can be anything there. Basically middle. Okay. Okay. Now you take the elements above 33 into one list, take the elements less than 33 in another list. So the less than is 23, 17, 5, 11. Okay. Now you say pivot 5. Right of 5. It is empty set. There's a flower brackets there, right? Then you go to the right set. So now 23, 17, 11. You pick the middle element as 17. Okay. Left set is 23, right set is 11. So once you reach one element, it's already sorted. So you're basically pivoting, dividing, and conquering each subset. So at the end of that process, you would have a sorted list. Now, can you imagine how can this guy come up with such an algorithm? It's a very interesting theory, right? How could he even think like that, right? It's not so bubble sort everyone understands, right? It's a very conceptual thing. Okay. 99% of the 99 out of 100 people would understand that easily, right? But how could Tony Hoare come up with an algorithm like this, which is not at all intuitive? The concept of a pivot and then doing less than the pivot. We don't know how they came up with this algorithm, right? That's why when we talk about programming, right? Program is an art that you come up with. There's a lot of art to it. Okay. So that's why he became very famous. Okay. Now again, you would not understand it by just seeing it on a screen here, right? What I want you to do is trace it. I gave you the methodology to trace it. Right? Another example for you and do this as an exercise homework and then you apply that quick sort algorithm. It's already in the slide deck that I posted in the community and trace it like that. Then see how it looks like. Okay. Okay, now let me go to the next slide. I give you some code there. The code would get a little bit complicated. For the purpose of this class, for now, you don't need to implement a quick sort yet, but later on during the semester, you can implement that. It's fun. It's a fun algorithm to implement. Okay. Um, let's ignore the big O for quick sort. Okay. For I'll give you the answer. Best case is n log n and the worst case is of the order of n squared, quicksort. Okay, so the worst case would be similar to a bubble sort. Bubble sort is also order of n squared. Um, Compared to other algorithms, n log n. Remember, I told you anything with log is always a good algorithm. Okay, like binary search, it's a log n algorithm, right? Because every time you're searching, you're cutting down half of the portion where you don't have to search. Okay, same thing with quicksort. Okay, okay, now, okay, I'll come back to this couple of these things later because you may or may not understand this yet. Uh, okay, I think I should stop there. I would not go to merge sort today. Okay, let me pause here. Questions, comments. So the fundamental thing about quicksort is choosing the pivot to summarize, left subset, right subset. Again, recursively you apply, choose a pivot to the left subset, break that down again into left subset, right subset. Okay, till you reach the atomic element. If you have one element, remember, if you go back to the quicksort here, what does it say? You once the list has zero or one element, it's already sorted. You don't have to do left subset, right subset, and pivot. Okay, so you know when to stop there by default. Okay, questions, comments? Does it look a little bit more complex than the simple algorithm that we have seen? Bubble sort, insertion sort, and selection sort. At least to me, it looks a little bit more complex. Okay. Um, what I want you to do in the remaining time, I don't know how much time we have, about 10 minutes, right? Do the tracing. Use the rest of the 10 minutes. Remember, I said I skipped the insertion sort tracing. Okay. And take the same data set. Okay. Take that 5 element data set that we saw. Let's see that. Where did it go? Give me a second. Take the same 5 element data set, 14, 33, 27, 35, 10. In the remaining 10 minutes, apply the same thing, the algorithm to this data, both for insertion sort and as well as for quick sort. Okay. So if I have 5 elements here, I'll give one hint to begin with, right? What could be my pivot map? 27 would be my pivot, right? And 27 would be my pivot, set with 35 and 10, correct? So then for 14 and 33, what is the pivot? You can take, say, 33. Okay. Then the left subset would be 14 and the right subset of 33 would be empty set. Okay. That's how you need to trace it. Okay. Use the 10 minutes. Go ahead and do the tracing for those two. And then you are done for the day. And next class when we come, after we summarize, we'll come to, I think you do have merge sort in this class, if I'm not mistaken. I'll look up your syllabus. Then we'll talk about next class, not today. Next class, we'll talk about merge sort algorithm. Okay. And that's a little bit more complicated. So I will save it for next class. Okay, mentors, please make them do the tracing for the next 10 minutes. Please, for the same data. You can actually increase the data size for the quick sort. 5 is trivial. You can come up with your own example of some numbers like a 10 element array and ask your students to apply quick sort for the 10 element array. Everyone understands it? Okay, where is my chat? Okay, I'm putting it here. So create your own 10 element array. Create your own 10 element array and apply quick sort. Okay. I see DMS SVHC people. Are you doing it? Actually, each group can create your own 10 element array. And then I'll put up the algorithm here for you, quick sort algorithm. Okay, I'll put it in a slide mode. Each group create your own 10 element array and apply that one. Trace it systematically line by line, then you would get it. Okay, I do see people are staring at the screen. Do you have a sheet of paper in front of you to do that? You should be writing the 10 element array. Create a 10 element array on your sheet of paper. Random data, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that. If you do that, it's an interesting thing. So create reasonably unsorted data. Okay, okay, now you're on your way. Aditya, I'm assuming you are able to do the same thing in your class. I'm sure Jane Usha is managing the class there, so I'm sure she must be doing that. I don't see other videos, but I'm assuming that you are making the students do that. Let them create their own 10 element array. I hope I'm not the only professor who is making you work hard in the classroom like that, right? Doing some stuff. I'm sure all the other professors would give a lot of in-class work like that for you. Usha madam, if I didn't say it correctly, you can correct me. Unless they do this stuff in the classroom, how will they learn? Remember, step number 4 is important. I do see JNTU video now. Okay, I'm assuming they are able to do the quick sort on a 10 element array, show the trace. I do see the madam there in DMSS VHC monitoring them. That's good. Thank you for doing that. What's your name, madam, in DMS college? You can type it in the chat window. That way I'll try to remember it next time. Radhika. Nice. Nice name. There used to be a heroine called Radhika. I don't know if you know her or not. She used to be my favorite actress growing up. Amazing actress she is. So students, do you like to do more such examples in every class that we do, or this is too much for you? If you like it, we'll do more. The pace of the class would increase if you have noticed. For example, some professors take the full 1 hour to explain quick sort. Okay, 1 hour or 2 hours maybe. Um, if you notice, I did not spend that much time on it. Instead, I'm making you do it. So you will see those kinds of things. There's no need to give you each and every step. You can figure it out. I give you the outline. You work on an example, and then you will understand it. JNTUV. How is everyone doing there? Good. There's nothing more exciting than watching students do their work like that, talking to each other, learning from each other. That is the beauty of interaction like that, right? Can someone tell me when is the internal exam? When you will have it? A midterm or on term? I don't know what the terminology is. Approximately when it will come and how many units we should cover by the time your that internal exam comes. We want to pace it accordingly. Okay, and when would the exam be? Okay, they are busy solving Antara Mira, or they have already solved Antara. Okay, August 8th. Okay, so August 8th and August 16th for UCEK. Okay, so Manamu, we should finish up to module unit 3 by first week of August. I got it. In theory, we can finish it in 1 week. Okay. So there's a mid two also? No, right? It's only mid one and then final. And then can someone send me some sample tests as to how these internal exams would look like? Not these exams look like. And I don't know if my mentors know it or not. We started what objective means though. Objective అంటే problem solving అనుకుంటాను. That's what you mean, right? Right? They're scheduled. They started later than when they were supposed to start, and then Murtiga scheduled some makeup sessions. So did you all talk to him about that? I told him I'll be happy to do makeup sessions, not a problem from my side, because we lost 2 precious weeks. That's 4 classes. That's almost 1 unit right there. To Chakravarti Garu to address that also. I saw some girls. Are they done or they had questions that they needed to ask their madam? ABR CET, I hope you are doing okay. Hope your students are doing stuff. If you have any questions or difficulties, challenges, please let me know. Aditya has been silent. Oh, Chaitanya is here. Good morning, Chaitanya. Good to see you. For some reason, I didn't realize you were in this class. Okay, technically 12 o'clock the class is supposed to end, but I'm seeing a lot of you are still doing it. That's good. I'm impressed. I'm honored to see that you're excited doing this stuff. Your lunchtime away. Okay, so if you have any questions, comments, just email them to me. Um, I'll be very happy to assist your students there. I'm going to post a few questions in the community. Tied up today and tomorrow, sometime tomorrow night, I'll post some questions. And you can post your quick sort traces in the whatever traces you have done, not only quick sort, whatever traces you have done, please go to the community and post them there. And you know how to post an image, right? You can image or a document or whichever way. You're smart, you can figure it out. Okay, post them there in the community. And those of you have, and what I want from faculty members is each class, I told you, please send me the roster of all the students and their email ID, and ask them the question if they have enrolled in community or not. And you can scan that sheet of paper and email it to me. Thanks everyone. Time to sign off.